Hey guys, hope everyone is excited about the demonstration this Thursday. We are group number 16. Our team consists of Aditya Jaltade, Wendy Zhang, Tao Yu, and myself, Akshay Gandhi. Our project topic is distributed C++ compiler. So let me give you guys an overview of what we are going to cover in this presentation. We will first talk about the idea behind selecting and implementing this project. Then we'll give you an overview of how the system is implemented and how the internals work. Then we will talk about the technologies used in this project and the various distributed systems concepts that we have implemented. And lastly, we will talk about the team organization. So let's move on to the idea behind the project. Our distributed system comprises of multiple nodes. Each of these nodes have different versions of the compiler installed and a bunch of libraries pre-configured. The system keeps track of such information regarding various compile nodes. A user just needs to submit the code that he wants to compile to the front end without having to bother about anything else. The system then splits the submitted job and offloads the compilation task to the nodes such that the job will be completed in a distributed fashion. A system is developed using commodity hardware such as laptops and desktops without the need for any special hardware. And like all good distributed systems, a system is pretty robust and fault tolerant so that the compilation can be completed fast and successfully even in the face of node failures and other errors. Now moving on to the features that we have implemented as part of our project. We initially only had the provision to submit a code for compilation to the web interface and through the command line. Then someone suggested that it would be really cool if the user can just use any IDE to develop his code and the code would be compiled using our distributed service without the user actually having to go visit our frontend and explicitly submitting the code to be compiled. And we went ahead and implemented this feature to our project. Our frontend allows the users to monitor the progress of the compilation in real time and also to check the history of the previous compiled jobs submitted by the user. The user also has access to the logs in order to get more detailed description about the compilation process. And not to overlook the fact that the entire compilation process happens in a distributed and fault-tolerant fashion while the user is completely transparent to the whole process. Now let us look into how the system actually works. As depicted in the picture, our system architecture consists of the client, primary and backup front-end servers, primary and backup bootstrap servers, and the compiler nodes. The user first submits a job to the front end for compilation. The front end is replicated in order to ensure high availability. The front end then forwards the submitted job to a primary backend server, which is again replicated for availability. The primary bootstrap server then selects one compile node as a super compiler node that is responsible for a particular job. The super compiler node selects a subset of compiler nodes and distributes the compilation task across them according to the requirements of the compilation and the capabilities of the nodes. The compiler nodes and the super compiler nodes exchange heartbeat messages with each other and with the primary bootstrap server for fault-tolerant behavior in cases of node failures. The status messages are also exchanged between the super compiler nodes and the bootstrap server. This keeps them up to date with the files compiled by the compile nodes, and this information can be used to display the graphics to the user. Only the files which were not compiled by a node need to be offloaded to other active nodes and not the ones that were successfully compiled. The user can track the progress of his compilation in real time via the front end. Now we would like to discuss about the technological and organizational aspects of our project. A complete backend is developed using Erlang. We found Erlang to be a really cool programming language, especially for distributed systems programming. It has many inherent provisions to support features relevant to distributed systems such as message passing, remote procedure calls, basic fault tolerance, just to name a few. We will recommend the future batch to definitely try Erlang. We developed a front end using the Django framework just because of its simplicity and efficiency. We developed a custom protocol in Python to enable communication between the front end and back end. it was a good mix of learning new languages and also innovating something new in Python. Now let's talk about the distributed systems concepts that we have applied to our project. We made use of noip.biz to allow for dynamic mapping of DNS, which allows a client to discover the web interface. Erlang exposes a global namespace for all processes that are linked together using a common cookie. This allows various compile nodes to discover these processes using global namespace. That is, they do not require IP and hostname configuration. This concludes the configuration part. Now let's move on to the fault tolerance aspects. We tried to achieve fault tolerance using process monitors in Erlang. Erlang has native support for monitoring processes. Whenever a monitored process goes down, all the linked processes are notified of this event and they can take corrective actions, which can even include restarting the dead process. However, this is tricky since the newly started process will need to have consistent view of the system. We achieve this consistency by storing important data related to various jobs in a replicated MySQL database. Our team was very well organized. We worked in teams of two. One team will look into the front-end stuff and the other team took care of the back-end development. We tracked progress of pending issues using email and took care of version control using Bitbucket, which is an online private Git repository. Also, in order to keep things simple, we decoupled the front-end development from the back-end development. We used to have weekly meetings to discuss about ideas and to set goals for the following week. Everything was very well organized. So that's about it from our end. We would like to thank Professor Nace and our TA, Kong Zhang, for guiding us all along and being so supportive. We hope you enjoyed our presentation and are looking forward to the final demonstration. We wish all the teams good luck for the demonstration as well. Thank you.